Hi guys, so in today's video I'll be discussing this table and block problem. So now here we have a table, right? So on top of this table we have kept a block, right? So let's call this block as block number 1, and on top of this block we have kept another block which is block number 2, right? So now in this question they are asking what is the balance position respectively for block 2 and 1 such that we can keep the entire system in the balance position. So here we need to find this length such that this will stay at a balance position, while at the same time we have to calculate this length also. So that is the problem. So now it's so practical. In order to have these blocks in the balance position, definitely the center of gravity should lie within the table region. That means if I consider the scenario for a single block, right? So for an example, now in the case of a single block, this is the center of gravity, right? So in this case the center of gravity is directly passing through the edge, right? So now this is the edge, because if you consider this table, this is the edge, EDGE, right? So at least in order to satisfy the minimum condition, right, so this center of gravity should pass through the edge. So even though this case is also you can't define as a balance position, sometimes in this case also it will fall down. So this is the most critical case. So this is the most critical case, right? So now, so like that, now we have to find the respected length for block 2 and block 1 such that it will stay at a balance position. So it's very easy. So what's the logic? In order for the balance scenario, right, definitely the center of gravity should lie on the table region. So now what is the table region? This is the table region, right? So this region, or in other words this length, is the table region. Okay, so I will hatch it like that. So this is the table region. So this is the table region and this is the center of gravity. Definitely, to not to fall down, this center of gravity should lie within the table region. So now in this problem we are going to find the minimum condition, right? So for the minimum condition, so right, at least this center of gravity should lie towards the edge for the minimum condition. So now let's calculate. It's easy. So we have this table, we have the lowest block or the block that is kept on the table, that is block number 1, and after that we have block number 2, right, which is on the top of block 1, and both of these blocks are having the same length, which is L. So this length also L and this length also L, right? So now if you are considering this single block, that means if you are considering this block number 2, right, block number 1 is like a table to block number 2. Okay, so now in order to satisfy the minimum condition, at least the center of gravity of block number 2 will pass through the edge of block number 1, right? For the the minimum condition for the balance position means at least the center of gravity of block number 2 should pass through the edge of block number 1, because this block number 1 is like a table to block number 2. So now I think it's so clear. So now we have very easily found the distance for block number 2, which is actually L by 2, right? So it's very easy. So now actually this is a multiple choice type problem, so it doesn't matter. Our target is to find the respected lengths for block number 2 and 1. So now we found the length for block number 2, that is L by 2. It's okay. So now we need to find that respected length for block number 1. So the respected length for block number 1 is this. So let's define it by x. Okay, so now in order to do the calculations for block number 1, guys, you need to isolate this block, right? So how you can isolate this block? That means you have to consider that this is the only block existing, or how to say that, so you can consider some sort of a resultant scenario, right? So resultant scenario means I will again sketch this. So now this is the table we have, right? So this is the lowest block, right? The block number 1. So now guys, you know, right, actually like these blocks are touching each other, but now I'm going to isolate this block 1, right? This is block number 2. So now we know, guys, the minimum distance for block number 2 must be L by 2 from this corner, that means this length, right? Because it is kept like this, right? So definitely the center of gravity of the block number 2, which is at L by 2 from this end, will pass through the edge of block 1. Understand? I am again telling, according to the minimum condition, the center of gravity or the weight of the block number 2 should pass through the edge of block number 1. So that means because of this block number 2, it will exert a kind of a downward force on block number 1, like R, right? So this is R, right? Just because of the weight of block number 2, it will exert a kind of a downward force which actually passes through the edge of block number 1. So that's no problem. So and now this R is actually balanced by the weight of this block, right? Or which is the block number 1. So now in order to balance this, in order to have such a kind of a balancing scenario, right, so we have to find what is the most suitable pivoting point. Pivoting point means now this table is appearing like a big thing, so you can consider this table as a pivoting point. See guys, something like this, right? So this table can be minimized to a pivoting point like this. So now see, so now this table is something like this. So now we have simplified the system. Actually this line indicates so block number 1, okay. So now on this line there is a downward reactive force acting R. Actually what is that R? R is equal to W, because W is the one which is exerting, because the weight of this block is the one, that means this W is the one that is exerting a reactive force, or the kind of a downward force on block number 1. So that means there is a downward force acting R, right? So now if you consider this block, so now what is this block? That is block number 1. This block number 1 is having its center of gravity, you understand? So now you carefully you have to find that balancing length, or like at what particular length it would get balanced. So again consider this block number 1, right, or the lowest one. That's the table, right? So now this is the downward reactive force R, and if you consider this block, the center of gravity of this block is right on its midway, measured as L by 2. Say the L by 2 is here. So now what is this W? This W is the weight of this block number 1, right? So now here we have this weight W, and also here we have this reaction force R. So will there be kind of an advantage if we keep the system like this? No, right? So no point of having the pivoting point over here, right? So now as I told you, like if this is the table, this table can be reduced to a pivoting point like this, and this larger table can be reduced to a, say, something like a line like this, right? Something like a line like this. Say the center of gravity of this line W is here and the reaction force R is here, so no point of having it like this. So that means we have to find what is that suitable, right? What is that most well defined suitable length for this pivoting point, right? So that's the target. So now actually this length x, right? Now here we have the pivoting point and there is a length, or there is a kind of a gap from this pivoting point and this reactive or this resistive force. Actually that length x is the distance we need to find for this block. Okay, so it's very easy. So now the calculation is very easy, right? Now the calculation is very easy. I mean, like this is a simple problem. You can even do this calculation within, maybe within a fraction of a second, but in this video I'm just trying to analyze it, like how you are going to analyze the theories. So no problem. This is block number 2. This will be the final diagram. This is block number 1, right? So no doubt, definitely for block 2 it should be right on the halfway of block number 2, which is L by 2, because the center of gravity should lie on the table region, right? So that I already explained you what is the table region. So now when you are considering this block, it is having a reaction and you have to find the suitable pivoting point. So now this is the pivoting point, this little triangle like thing, right? That's the pivoting point. Okay, so now it's very easy. This must be the pivoting point, and in order to have the balanced position, this must be the center of gravity, right? So no doubt. So this is the reaction force. So without any doubt, you know this length. So what is this length? L by 2, right? What is this length? You don't know. That is x. So now you can write the equation for the like torque balancing, right? So if this length is L by 2, if this length is x, so how can you balance the torque? It is easy. This is producing a kind of a anti-clockwise torque and this is producing a kind of a clockwise torque, right? So this is L by 2, this is x. So what is this small distance? L by 2 minus x. So now you can say W times L by 2 minus x is equal to what? This R times this length, which is x. Actually you know R. What is R? R is equal to W. W is the weight of block number 2, because block number 2 is the one, the weight of block number 2 is the one that is exerting that force. So now it's very easy. So R also will become W. So W into x, W times L by 2 minus x, right? So now you can do the calculation. WL by 2 minus WX and WX. So you can take this to the other side. WL by 2 is equal to 2WX, right? So W is actually getting cancelled. So x is equal to L by 4, right? So that means this x length is equal to L by 4. That means the distance uh, to the center of gravity of the block number, distance to the, not the center of gravity, distance, right? Distance, so this x is the distance to the pivoting point of block number 1 measured from the extreme corner of block number 1. So that is the distance x. So now that x we calculated as L by 4. That means, so now it's very clear, the distance for block number 2 measured from the extreme edge to the pivoting point is L by 2, and for block number 1, in order to have in the balanced position, the distance measured from the extreme right end to the pivoting point is x, so that is L by 4. So the respected answer is L by 2 and L by 4. So now it's very easy. So right, so now you can do even like, even if I have given the same problem, even by increasing the number of blocks, right? So no problem, right? You can even do these kind of problems now, because now you have the logic, so now you have the theory. Okay, so be when you are solving like this kind of problems, be very careful about the notations, right? So like that, I am again telling you guys, in this block, right, actually what is this x? This x is the distance to the pivoting point, right? Distance to the pivoting point of the respected block 1 measured from the extreme right end, right? Extreme right end. So what, this is our right side, right? So what is the extreme right end? So this is the extreme right end. So distance to the pivoting point measured from the extreme right end, so this is that distance, right? So those are the cases you have to be very careful, right? So now I think it's done, right? So now I will summarize the mechanism, right? So now I think I can summarize the mechanism. So this is the problem that they have asked, right? To find this length y and this length x, right? So our method plan is, first find y. How we are going to find y? Practically, right? Practically, by practical science. So what is the practical science? The center of gravity should lie within the table region, right? So in order to study that, just consider a single block, right? Just consider a single block rather than considering 2 or 3 blocks. Just consider the single block, right? If you consider single block, the center of gravity will be right towards the mid. So now if you consider this case, the center of gravity has reached out of the table region, right? So it is not in the table region, right? So that means definitely this block will uh, tend to fall down. So that means practically you have to analyze y. Then you have to analyze block 1. So how you are going to analyze block number 1? That is by calculations. So now when you are going to analyze block number 1, what is the next thing you have to do? You have to isolate, right? You have to isolate block number 1. So how you are going to isolate block number 1? This block number 2 is having its weight, right, through the center of gravity of block number 2, so that will definitely pass through the extreme end of block number 1, right? Extreme end of block number 1, that means R, right? So that means now if you know the exerted force on block number 1, by block number 2, that means you can now isolate this system. I'm like, you can just sketch it like a some sort of a rod like this. So now this R is that reaction force. So definitely, the next thing that you have to think about is what would be the supportive force, because now here it will generate a kind of a couple. So in order to balance that couple, there should be other supportive force. What is that other supportive force? Is none other than the weight of this block, or in other case this rod like thing, if you're going to simplify. So that is W. So now the next thing is you are going to find the suitable pivoting point. So that's it, right? This R is acting at the extreme right end, so this W is acting at the right mid of this bar, right? W is the center of gravity of block number 1, so this is acting right on the mid of the bar. So this length, you know, which is L by 2, right? These forces also you are knowing, this is W, this is reaction that is equal to W. So so now no problem, the only variable is this X, right? So to that you are going to write the torque equation. So that's it.